The great thing about SwiftUI is that it automatically handles all the updates. You basically only need to say what you want to have, and SwiftUI does the rest for you. It does the updating, redrawing, refreshing for you. Unfortunately, with this magic comes a drawback because it does everything automatically. Sometimes it does too much or it doesn't do it the way you think it should be. And these are situations where it's quite difficult to find out what's going on because internally everything is handled by SwiftUI. So how do we, if we have a performance problem or something is not going the way, how do we find out what's going on? And in this video, I'm going to show you 3 strategies. So we're using instruments, the debugging, and some visual hints. Because testing can be very different depending on the situations, it is actually very important that we practice this. So in the upcoming videos of this series, I'm giving you other examples that we then go through together and see what we can optimize, why things are the way it goes, so you can then actually practice what you learned today, what you see. Now, the project that you see here, you can find the link in the description box so you can follow me along and test this a little bit yourself. I already put a couple of views with different versions. Some of them work well, some don't work so much. So let's see if we can find what's the difference between these different implementations of views. I have here this navigation split view. I have here this view where on the left you see a list of data entries. I pass in here the data itself and another view model. The view model I need because I want to have here this button and I just need to call an action in this view model. Then below I have an H stack with 2 buttons, one for adding a new entry in this list. I just added here another dummy one. And a toggle because I want to do some regular updating. So every second this toggle is running. This property is in the view model. Then on the right, I've just added here another list where we see the same data entries. In this case, you can actually change them. For example, I can change the name. This is the first one. Here, change the title of this entry. Usually on iOS, you would do this probably in a detail in navigation stack. I use this as an example for how complicated these updates can be. I have here multiple views that use the same data, that manipulate the same data, and want to see what is refreshing and what is not. Now I actually want to know when SwiftUI actually updates which view. Right now it looks like it does it properly, so I get the updates I need to get the new data. But I have a performance issue because actually SwiftUI does too many updates. My list is really small, I only have here 4 entries, but if you have a lot more and you add some calculations, the performance might be a problem. So let's see what's going on. Now it's the time for our first tool to test our performance, which is instruments. So under products, I use profile or just command I. Instruments now launched and asked me which tools to use. It already automatically selected SwiftUI because it's the one I had last time. There's a lot of different things you can measure. This is because when you use instrument, it actually collects a lot of data and it will be sometimes a little bit overwhelming. Also, it gets a little bit heavy. So that's why they have here multiple tools. I want to here use SwiftUI. This now opens the main window where I have here just 4 different lines. Right now I don't have any data because we didn't start a measurement. On the top left, you press this record button, start an immediate mode recording. This will then start the last build project. For me, this is on the Mac. If you are working on an iOS app, then it's best to run this on an actual device to get proper data. I mean, I'm running here on my Mac, so this is for macOS app, the proper data. Now you see here this line moving and we are starting recording. Let's see what happens when I press here this toggle timer. There's some measurements going on here. Something is happening. I'm stopping this and I stop also this track with the top button. Now, in this timeline, this is the time axis. I only recorded up to here 22 seconds and you can zoom in with a magnification gesture. So I just increase this and then I can look at all the tracks that we have. So here this is the events that happen because of my timer, the 1 second timer. So this is at 12 seconds, 13, 15 and so on. Now I want to actually see the things that happen in a certain time interval, so I can tap and hold to select a time interval. So now I'm just focusing on the event of my timer is changing. I select the lane for view, and then down here in the inspector we see more details. So we can look at the view bodies that are created. So you have a SwiftUI your view and then your body property. So I have my observable object example view, and this has one body property that in case something changed and some of my data changed, I need to recreate this, redraw this, and to refresh and see my new information. So in this case, if you choose the view body, you see what actually updated. Down here under modules, we have two options, either SwiftUI, this is all the views that SwiftUI created, like buttons, text fields, or you can choose your own project. I didn't use that many views, I only have two, which is the example view and the raw view. So here in the list that is on the left side, I have a for each and a raw view, so this is the view that it needs to create. The other views that I use here, like here buttons and spacers and text, these are leaf views, these are SwiftUI views, so we won't see them for our example. What you get is the views that you define your custom types. So in this case, we see that when my timer changes, this example view updated. This is correct because in this view, one of the views that I used is here, this text field where I show the timer down here. This is exactly what needs to be updated. So obviously it needs to go through this view to check and update this. My raw view here doesn't actually rely on any data, doesn't show any data from my view model, where this timer property is in. So it would not need to update because nothing that is shown here relies on the data that changed. However, we see that raw view actually was recreated 4 times. I have 4 rows in total, so all of my rows actually updated. Let's see what happens when the next timer changed. I have again 4 raw views that updated and my example view that should update. And this is going on for the next ones. Now, I don't really see why this raw view should update because the data that it uses there's nothing changed visibly for us. So it actually shouldn't need to change. And this is why they have here another lane for view properties. So I tap on this one. I stay in the same selected range. Now we see the first column is the module. Again, you can check, SwiftUI internally has a text field which relies on a binding property which changed to Sunset Beach. If I go back to my example, need to refresh this. Here on the right, I used text fields. So this is a text field where I give a binding to the inspiration's name, and one of them is in Sunset Beach. This is what you see here. A SwiftUI internal view with the view type of text field. The property type is string, has a new value of Sunset Beach. Doesn't really make sense because this actually didn't change. Now, this is indicating that we have a problem with too many updates. Now, let's just focus, instead of these SwiftUI views, which are quite a lot here, let's focus on the views that we had. So I can tap here on this module to sort by so first now I have my own custom types. You can also use here this input filter of say, okay, we had a problem with the raw view. Let's see where this is used. Now going back to all of them, I have here 4 raw views with the view type raw view. Then the third column is property type. That means which property caused this view to update. We see here it's an observable object of type inspiration view model. It has a new value. This is a little bit tricky because now I can't here see the data that changed, but I have a change in this view model, inspiration view model, that caused this view to update. Let's have a look. I go to my raw view. I have here multiple of them if you care. Now in here, this body was recreated because one changed, which is an observable object of type inspiration view model. So this, something in there changed. Now I know that if I go here, it has only 2 properties. So if any of these properties changed, and in this case it's my time remaining, or this timer here that changed, the views that use this view model will be updated. Even though in this case I actually don't have here a use case for this. But because I declared here observable object var view model, this is a dependency of this view. And one of the problems is using view models or observable objects. It just does too many updates. Okay, now let's have a look at an example where I fixed this. And this is the reduced dependencies, where I didn't pass the view model itself to this raw view. I only passed in here this action call, just so that I can press this button. Okay, I go back to instruments and I press the measure button again, which opens another window. Now I go to this reduce dependency tab and start my timer here again. And stop. Now we see here these lines. Okay, I zoom into the elements that I care about. First in the view body to see how many updates I have. And now I only see here my observable object, this main view that was updated. This is the view because here I use this timer property. None of the subviews actually updated. This is great news. This is what I wanted. Let's check what the view properties did. So again, so now I only have here 2 entries and I don't have any of the raw views. My example view here changed because this view model changed. That's what I wanted because the timer property changed. The other one that is in here is actually the selection. I don't really know why it does this. This is in the content view where I have a navigation split view. In the sidebar I have here a list where I can select something. This list has a binding to a selection property. And my value was here observable object. So this is a state property with this value. Now let's have a look again at instruments. It's in the content view, a state object of an optional selection type. This is what we saw. You always see these types. SwiftUI works more with types to manage this. And I see here the new value, which is reduced dependencies. This is the other tab that I then switched to. When you look at instruments, you have here, the interesting thing is which properties changed. So we have state objects, observable objects that changed, which I had in the other example. So if I go here on the tab, I can go back and forth between different measurements, and I can also give them different names. So I remember here, this is the reduced dependency, the improved one, and the other one was the observable object everywhere. So in this case, for the view properties, I saw here that in my raw view, an observable object with this type changed. Whereas in the other, when I improved this for the improved version, I don't have this state object dependency. What you can have, views can be updated for state objects, state bindings, observable objects. You can also have here focus state, environment properties. Now, I also want to show you the results when you use the new observation feature. So now I don't use observable objects and state objects. I use this observation. So this is in the observation nature inspiration, this is data. So I changed this to a class, observable class. And the view model also changed to an observable class. I used the same data, the data for this list and the time remaining, the timer. So this is then this observation example view where I used this data flow. Now let's test this. So I start my measurement again. I go in this tab with the new observation feature. I start my toggle timer here again. In this case, actually, I used also this property in this views. So in this raw views. So I stop my measurement. Let's see what happened in this case. In the body property, I have the main view that changed because I used this timer there. And then I have here different subviews. This is a text subview. Let's look for this. This is the one that I used for this elements here in this raw views. Okay, I go into the selectable preview and then I double tap on this. So we go here in this text subview where I used from this observation data the time remaining again. So it only needed to update this sub view that I used in this raw view, which is exactly what I wanted. I don't need to update everything else. It's just this sub view that needs to be updating. And because of this no observation feature, the data flow is much better handled. So it only updates when properties also in the view model that are needed in the view that are displayed will be updated. Now in instruments, we see that we really only update the views that we need. And let's see what view properties cost this. So again, I have here my content view that was the same as before, and this observation example view, the list where the state changes for this observation data. And in this case, it doesn't even show me the sub views. As you see, you can use instruments to check which views were actually updated at which point in your app, and which properties or dependencies caused these updates to happen. You can also have a look at the core animations to see how many redraws, how heavy these were actually. Time profiler, if you want to look for code that was used quite a lot. Maybe you calculate something. When your views change, your data changes, then you calculate something. There's quite a lot of other instruments to use for this, but for SwiftUI, this view body and view properties is quite interesting. Now I want to show you the second strategy, which is debugging in Xcode itself. So first you can set breakpoints. Let's say for my observation example, where I used here this bad performing data flow. I want to know how many times raw view was created. So I go into the sub view, and here in body, I put a breakpoint. Maybe I should just undo this first and rerun so I don't get so many I don't hit this breakpoint directly. Okay, I set the breakpoint. Back in my app, I start this timer. And we get hit. So now we know this body was called when my timer was updated, but I want to know why. So you can use po self.underbar.print changes, and we get a view model changed, which means that one property in this view model, observable object, changed and caused this view to be recreated. I can then continue to the next one, and we see this is actually called quite a lot. So I uncheck this. Again, I know the dependency to this view model because all the properties like the inspiration or view models are dependencies for this view, and because of when one of them changes, my body is recreated, and I refresh this on screen. Now let's see what happens if I here change this data. So again, add this breakpoint, and I change. Now with this breakpoint, it's a little bit slow going in this case. I just want to know how many times this is actually hit and see something in the console. So I am deleting this breakpoint, and I'm going to use the same style of self.underbar print changes. This is because of this underbar, it's actually a system API, which was only introduced in one of the discussions during WWDC in one of the developer forums. So actually, it's not officially an API, and you should be aware that it can change at any time. So I can use here let underbars because I don't care about the return statement, and I just want to return here my HStack. Say self, capital self, dot underbar print changes. So now every time this view is recreated, it will print the same statements as here. Which view changed? So my raw view, and why did it change? So let's run. The first time this view appears, I have here 4 print statements because I have created 4 rows. So each of these rows is created. That's what I want. Now it gives you information of why it was or what properties changed. This is similar in the instruments what properties cause this. And you have here different ones. So self means the view itself with this identity, with this data was created. And the view model actually changed. This is just initially you will always see all of the properties. Now let's see what happens. I'm just going to delete this. What happens when I change one of these texts? So now my data actually changed here. but only the first one. I have here again this 4 times going through this raw views that is recreated, the body property is called. 3 times the view model changes because this data is inside the view model. And as I said, if anything in the view model changes, we have here a call to the body if you use the observable object. But one of them actually changed. Self means that a property, this inspiration, this data here actually changed. The view model also changed because this also lives in the data. Now you saw that I have self and identity. Okay, now the last example is when I press here add more, I will add 1 more row. Now I have 5 rows, and again we see we have called this 5 times. So 5 of these rows are recreated. And the first one is the new one. And we see here self, identity, and view model. So every time you see identity, this is related to creating a new row in this list. Self means a property changed in this row. Now you can have a look at the definition behind or the help for print changes. So this is when called within an invocation of body of a view of this type, prints the name of the change dynamic property that caused the results of the body to need to be refreshed, as well as the physical property names. Add self is used to mark that the view value itself has changed, and add identity to mark that the identity of the view has changed. In general, that the persistent data associated with the view has been recycled for a new instance of the same type. So identity, this recycling, if you are used to UI kit with UI table views, where you have reusable cells. This is basically if you use a cell for a different entry, for a different data point. Now, I struggled quite a bit with this self and identity. There's some good talks about that also talk about these problems here of when views are updated and refreshed, dependencies, and I will link them in the description box. One of them is Demystify SwiftUI, and the other one is Demystify SwiftUI Performance. This is the talk from 2023. Now, in order to give a good example of self and identity, I'm going to do the most obvious by explaining this and teaching you some German. This is because in English, the word same has 2 different translations in German that highlight a different aspect, which is quite nice in this example. And this identity crisis that we're in, it's maybe a little bit weird to explain something that is already difficult with something other that is difficult, but some friends that learn German, they were struggling with this 2 different concepts because they're not used to it in their own languages. And the example they gave me from their class is this sentence, and it has 2 different versions. If you say the sentence in one version, people probably look at you a little bit weird, with a little bit of disgust. So this German sentence is, ich trage jeden Tag dieselben Socken. This is the one you probably shouldn't say. And this means dieselben means I wear the exact same socks every day. You probably would, in a normal conversation, you would say in English, I wear the same socks every day. Whereas the other sentence is, ich trage jeden Tag die gleichen Socken. I wear the same socks every day. In English, you would use the same thing, the same and the same. But in German, we use 2 different versions and they have 2 different meanings. In the first case, you have 1 pair of socks and you wear the exact same socks every day. They're just changing a little bit. They're getting more smelly every day. This smelliness is just, it's the same sock, the same identical, it has the same identity, the socks. But one of these properties changed. The self changed a little bit. In this case, it is a property of smelliness. Maybe also looking a little bit weird. In the other case, where I say die gleichen, I mean I have 10 pair of the exact same type of sock, the same type of socks. Only that I switch every day to a new pair of the same type of socks. when I talk in English, I have a problem with a little bit of the wording, what we mean by same and exactly the same. Exactly the same means it has the same identity, the same pair, the identity with the same pair. If you put a tag on this socks to know, maybe you were having a tag of Monday, Tuesday, and Wednesday for each sock. This is the identity of each of the socks, and you just cycle through them. Visually, they don't look the same. Now we have these two different words in SwiftUI with the print statements, the identity and add self. When we see identity, this means it is a new sock. This is the Monday to Friday socks thing. The identity, it's a different sock. It's not the same sock. Whereas if we see self, for example, when I change the name here, now here, when I change the title of this, you see self changed. This means basically it's it's the same sock, but one of the properties changed, self changed. Funnily enough, with these examples, you see dieselben, self, it's the self, that's the German word for self. Maybe the person who made these names was German and they just liked self. So, okay. So the way to remember this, if you see self, it's the same data, just one property changed. Self changed a little bit, your socks got more smelly. Whereas if you see identity, it means it's a new sock. It's a different sock, but the same type. In this case, it's the same of type raw view. That's the same raw view type, but it has a different identity because the data that is associated with this raw is different. In SwiftUI, this identity of views is quite important. And with this print statements here, you get information of, if you see a lot of identity changes, you have problems with the way you're identifying data isn't that great. And this is, the example I have for this is for another project, I wanted to make a little gradient and that the user set up here this gradient. So I thought, okay, I need to just have a list of colors that I want to allow, and I show them here in a list, and for each of these colors, I add here a picker where I can change the color of this. So this would be going from red, blue from green, blue to red. So when I select here, this picker comes up and I can change this. Now this is pink. You see this changed, but now if I want to test some others, it doesn't work anymore. My picker changes, but the one in the list doesn't. Weird. Let's see what I did. So in this color list view, I have an array of colors and then a list with a button to add a new color, where I just add a new red color to this list. And for each, where I use a binding to this colors array. And for each of these colors, I show here a color view with just this color picker. You might as well directly use here the color picker. But I wanted to know what's going on with this, so I extracted in the subview. And because color is not directly identifiable, so I said, I don't care, I just use ID self. As you saw, this was not ideal because, my picker doesn't work properly. So let's use another print statement here. So let underbar self dot underbar print changes and run this again to see what the hell is going on with my view. I go in the color identity view here. I go to red. I have here the print statements. Before that, I'm just going to clean this area so we know which ones belong to my action when I change this color. And I go for pink. And we have here a identity change. The identity of this color view, this raw, changed. Because for each, these views are identified with this identifier. So it knows this is the view that I have. And in this case, because I changed the color, which I use to identify this view, it thinks it's a different view. Which means that the connection between my color picker and this raw that I have broke, because it's still, this one is connected to the one I had previously, which is gone. So this is not doing it. The other thing that you have, if I add a new color, and it's just going to delete this. I have now one red and I add one more. I actually have here 2 times the same color. And on macOS, somehow it doesn't give me these error messages on iOS. It tells me the ID for each has a problem because the ID red occurred multiple times within a collection, which gives undefined results. This is another good hint, because now it has 2 times the same view here. If I change the color from one, it actually changed it in the other one. It also breaks here the selection with this view, because if you select this, there's a little bit of shadow around it. This is also broken because my identification is not good. And you can see this here with this identity. It thinks now it's a different cell, which it's not. Now the fix I did is to create a color data where this is just a wraparound color, and I used here an ID, UUID, that I can use, which is not changed. It's not dynamically changed. I never changed this, so this connection shouldn't be changed. So this is the other example here. Now these are properly identified, these views. If I add a color and I change this, I can actually, this connection stays because the ID with this cell never changes, so this updating works properly. One thing more that I learned is why it's really bad idea to use colors directly as the identifier. Now, with these 2 methods, you have to put quite a bit of work into and look for things that changed. And you need to really put some effort into this. But I actually want to have something that is more visually directly giving me feedback. And we're going to use a trick from Peter Steinberg, where he put a background with a random color. This is useful because I said when the views are recreated, like here my raw view, when this is recreated, the body is recreated. And because it's a random color, it's because we now actually see that it's a fresh view, the body updated. We have a feedback, so I add a background with a color.random. So this is in the project here where I added an extension to color. We can set a random color. I set here different opacity value because sometimes these colors are a little bit too much. And I still want to see my main views. Okay. I'm adding this background color now to the worst situation for my observable object and for the reduced dependencies. So both of these raw views. Now I have here this colored backgrounds with a random color. If I start my timer now, you see every time this timer changes because this view model changed. These raw views are recreated and I visually see that my colors change. So definitely not something that I want. If I go to the reduced dependencies, and now in this case I try the toggle timer, none of these colors change. I can also test this for different situations, like, because usually you need to test, is this changing something for this, or this? I directly can test all 5 versions here by changing the title, and only the first row is updated. Or I can also add here one more. And the rest is also constant. This is great, what I wanted. This is so convenient. And also I don't want to ship this in production. Then I added another convenience modifier, which is test background. So in this case, I added here flags for debugging, so I know I don't ship this in production. And I can also toggle this, turn this off and on for multiple places if you want to. You can also use this in the list background color. This is a very handy thing to do and much more easy to know what's going on. Okay, if I change something here, is something updated there, which I didn't want to. The thing with this is that you should not use this directly on the for each. So here I have a list with for each. Shouldn't do it here because then it will be evaluated all the time. This is because when my timer changed, this view is recreated and then it goes, and SwiftUI actually needs to go through this body and check which views actually need to be updated. And it goes through this for each to check, is something changed? Because of my background, it actually changed this. So they actually did not recreate the raw view, it just evaluated if it needs to be. So don't put it here, put it in the subviews. In the where you want to see which body is actually updated. So Best is to put this at the end of body. Now the thing that it does not give me is my problem here with the identity. My colorful problem here, I want to also have a visual hint of if I'm in an identity crisis. I mean, if I didn't manage to properly set up the identity of these views. And one thing that is related to the identity of views is state. If the identity of a view changes, the life cycle of this view is ended, and SwiftUI actually internally tracks all the state properties with these views. So what I did is I created an animated background that owns state. When this view appears, I change the state. So I'm here just drawing a rectangle, and I put this in the background similar, so I have another test animated background modifier. So let's go in the observable and add this. So I have here two different versions. Maybe you can change the names. So test animated background. This is for identity testing. Probably should name it as test identity and test redraws. So in the beginning, sometimes it doesn't really show it the first time. This is especially with the view. Sometimes this is not called with a state. So if I now add one more line, you see the animation here. This is because I put this in the overlay. It's actually in the overlay. So when this view appears, initially I have a full rectangle. One is red and the other one is blue. I set the visibility to true. So I actually hide this here with a little animation of 1 second. And then when this is changing, I am using here trim to change the border here. So then in the end, it's not visible anymore. So that's what you see here. This one is created. So this is related because state changes are related to the identity of views, to the lifecycle of views. Whenever you see this, the identity changes. Although I probably should have used this here. So to my color view, I add a padding or the speaker and a test animated background. And I probably should do this for both cases. So going to my problem here, I add a color. So it doesn't really like it with this color picker. I'm just going to add a stack color, and then I add to this one a test animated background. This is a bit of a problem with the testing. So when this appears, now this is actually doing it properly. You saw this animation. Down in the console, we see, this color views are created. They have a new identity and self. That's why my state changes are visible. Now if I add a new color, I see this here now new. If I try to change this one gets a new identity. You saw the animations. Now this one got a new identity. So I have whenever you see it, there's lines, then it was just a visual hint. I needed to have something that shows me this. I know that my identity, I didn't use the identifiable protocol right, or the identity of this view is not correct. In some cases you want to have this, in some cases you don't. This is another trick that you can use. So you have now this colorful backgrounds and this borders that show you. In this case, you see every time I add a new list, this is a new cell with the same type and a new identity. Okay, this is a wrap up of a very long tutorial where we had to look at how to use instruments, how to use print statements, and how to use visual hints. A lot of the times they can be used for different purposes, and some of them are better suited for different situations. For example, if you have a very complex app with a lot of views, and you just want to make sure that everything is updated correctly or not too much, you would probably start with instruments and then see, I have one of the views is updated quite a lot. So this is probably an initial hint of, this one has a problem with the performance. And then you can go in SwiftUI and add here this print changes or use this colorful backgrounds to get more information. I now showed you more about these different strategies of finding the problem or measuring the problem and identifying what's causing the problem. In the next parts of the series, we go into individual situations. So we will, for example, go through here this example with the observable objects, and then step by step check different solutions and use these tools again to see if we actually got what we wanted. So then is the discussion more about applying, and this is going to be multiple examples. On one hand, it's practicing debugging with SwiftUI, and on the other hand, also I'm going to show you some of the most common things you can do wrong and how to prevent them and how to do this correctly. Because there's quite a few things to look out for, and SwiftUI works in a certain way, I also prepared a little cheat sheet of what are the most common mistakes with SwiftUI and what not to do, what to do. So it's a little checklist that you can go through so your apps perform better in the future. Don't forget to subscribe to this channel if you don't want to miss anything of the upcoming debugging sessions. Like this video if you want to see more of this debugging things. Until next time, happy coding.